Please welcome Senior Vice President and Chief Product Officer, HPE Aruba Networking, David Hughes.
Good morning, everyone, and welcome to the 2025 HPE Aruba Networking Technical Keynote. As is our tradition, we're going to have a session that's packed with live demos showing our recently developed capabilities. We'll also be having some guest speakers and talking a little bit about some of the technology we have coming from further down the pipeline. I'm super excited about the lineup that we have this year. And what might be a relief for some of you that have been to atmospheres of past, we won't have our resident comic, Dan the Man, disrupting the show today. Okay, so I want to start out by outlining what I see as 5 key challenges facing IT today. The first thing that we see is demanding users, whether it's students in a school, patients in a hotel, patients in a hospital, guests in a hotel, or workers in an office. End users are demanding more. They're expecting a perfect experience, no downtime. They're wanting to be able to use new tools. They want to be secure and know that they're safe, but they don't want any hassles or roadblocks. Delivering this experience falls on you, and it's only getting harder. At the same time, the business is asking you to do more with less. You've got the same sized IT team, the same budget, perhaps a smaller IT team, a smaller budget, but you're being asked to do more, deploy new apps, improve performance, get better security posture. All it has to fit into a fixed size box. At the same time, cyber threats are becoming more serious every day. The traditional methods of detection and response are not working as well. Segmentation is becoming very complicated and brittle, yet you can't make excuses. You have to be able to defend. And then the world has changed a lot in the last few quarters. People are sensing a dramatic rise in geopolitical risk. This means many organizations are concerned about how do they make sure they have good business continuity plans for when services are disrupted, when interdependencies between different parts of the internet could be blocked or disrupted. They also want to make sure that they're protecting their user data and their own trade secret and secret data from being stolen or falling into ransomware. So those cybersecurity threats are very, very key, and the geopolitical situation is only making it more complicated. The 5th challenge that I see, for most of you, you run multi-vendor. And for you, having siloed operations where each vendor gives you a tool, but it only works in that environment, means everything's siloed, everything's much more complicated than it should be. And the other thing, which I think is fairly obvious, is that problems span domains. When you get a trouble ticket, they generally don't neatly come in buckets. This is a networking problem, this is a storage problem, and this one over here is a compute problem. You get problems, and you have to figure out which domain it's in, or if it's affecting multiple domains. So what we need to be able to do is help you with that multi-vendor, multi-domain challenge. So in summary, these are 5 very significant challenges. Maybe you're not facing them all. Maybe 2 or 3 are top of mind for you. But whatever the case is, we've been working hard at being able to equip you with the capabilities that you need from us to address these challenges. And we're going to demonstrate these today. Now, all of these challenges are really driving a rethink of what networking is all about. Networking doesn't begin and end with access points and switches. Yes, the devices themselves are important, but what's needed is something more comprehensive than that. We need security that's baked in, not bolted on. We need a control and management plane that's architected so that you can implement zero trust principles. We need to be able to harness AI to improve user experience and deliver operational efficiency. That's what we're doing with security-first AI-powered networking. Now, the foundation of this is Aruba Central. It's a layered architecture mapped to three fundamental requirements. There's a connect layer built from unified infrastructure. So we have a very broad range of APs from indoor, outdoor, hospitality form factors, industrial form factors. We have a broad range of switching, all the way from very small switches through to our biggest data center switches. Gateways, 5G bridges, 5G small cells, you'll see those later on today. Various ways of doing IoT connectivity. That's the connect layer. The protect layer is where we bring security to the table. So tracking identity, monitoring, authentication, being able to implement global policy and segment, to be able to enforce in the individual devices as well as in the cloud. And then the third layer is the automation layer. And this is where we're leveraging AI to deliver operational efficiency for day 0, day 1, and day 2 operations, turning your admins into super admins. Now, I think most of you know Aruba Central has been around for almost a decade now. And over the last couple of years, we've been hard at work upgrading the experience with New Central, which is a new API, a new UI. It's very, very snappy, fast. We've infused AI into all of the workflows. And for many of you, when you log into your Aruba Central account, you're in the New Central UI by default. Today, all the demos are in New Central, so I think it will give you a really good sense of the progress that we've made. Now, at this point, many of you might be thinking, every networking vendor has a cloud-native management system, and every vendor is talking about AI. So what's special about Aruba and HPE Aruba Networking Central? Well, there's many things, and you'll see a lot of them today. But to start out here, I want to pick three big differences, three fundamental ways Aruba Central is far ahead of the competition. So first up, let's talk about full stack. When we say we're full stack, we don't just mean we have APs and switches that work well together. We mean that we can deploy and manage with Aruba Central all types of location, from the smallest branch to the biggest campus, to the largest stadiums, to data centers. And you know, as we think about what AI is doing to the network, that data center capability needs to become more distributed. You've got more data centers. Most other vendors, if you want to do data center management, you're using an entirely different tool set than what you're using for campus. But with AI and the distribution of compute and GPUs, this is a blended problem. You want to have one management system that can do all of it. The other way of thinking about full stack is the breadth of the devices that are managed. So as I said, it's not just APs and switches, but it's gateways, our firewall capability, our 5G bridges, our 5G small cells, all of the IoT connectivity that we support. So that's full stack. Next up, flexible deployment. For many vendors, their cloud-based management system is effectively a one-size-fits-all, my way or the highway. If you want to use their devices, you have to use their cloud management system. It's a public SaaS service. You subscribe to it, but that's the only way you're going to get what you want. What we've heard again and again from you is that many of you have compliance concerns. You're worried about the geopolitical risks I spoke of. You want to be able to have more control. You want to be able to run on-prem, or maybe you are okay with being in the cloud, but you want it to be in your VPC with your encryption keys, where you have control over when things are upgraded. Or you might be in a country which needs sovereign control of its infrastructure. And so what we've done with Aruba Central is develop a cloud-native system that works great in the cloud, that delivers a great public SaaS service. But we didn't compromise. We made sure we can bring that same software with those same capabilities, the same advantages, and run it on-prem, or run it in your VPC, or use it in conjunction with service providers or partners to deliver country-sovereign management solutions. That's a huge difference, and I think some people might say that with the geopolitical environment, we're almost at peak cloud in terms of people consuming public SaaS services, and that there's going to be more of a trend towards people wanting country-based control or their own control. And so we are really excited that everything you see today with Aruba Central, we're working to be able to have that available for when you're on-prem, when you're in a VPC, or when you're doing a sovereign deployment. Now, the third big difference is multi-vendor observability. By leveraging OpsRamp infrastructure, we're able to bring telemetry from our competitors' products into Aruba Central and into our data lake. It means that, first of all, you see on the UI, when you look at the topology, you see everything. You don't just see our switches and APs, you see the whole network with all those other vendors' products in there. But it's much more than about seeing something in a UI. It becomes really important if you're going to talk about doing AI operations. You want your AI to be able to understand the full network topology and understand what's going on with all the devices. You want to know when a device was upgraded or rebooted, regardless of what logo's on it. If you want AI powered, you want it for your whole network, not just a slice. And so I believe that with the work we've done with OpsRamp, we've really taken a huge leap forwards in terms of being able to offer you multi-vendor observability and multi-vendor AIOps. If it was just the observability and the pretty pictures, you might say it's a nice to have. But if you want to do AIOps, that AIOps has to be able to see everything in your infrastructure. And following on, kind of the next step here is just seeing everything in the network is also not enough. You really want to be able to see cross-domain. And so as we are bringing OpsRamp into GreenLake and Aruba Central into GreenLake, all sitting on the same information bus, so to speak, we are able to bring multi-vendor, multi-domain capabilities into play. Anyway, I think you've had enough of a monologue from me. We've got to get into those demos. So I'd like to welcome to the stage Miles Davis. Miles.
Hey, David.
So what do we got coming?
We've got 3 exciting demo segments coming up for you. We've got a full stack segment, we've got an AI segment, and we've got a zero trust segment.
That's great. And you know, we actually have a bonus. There's more. Following your demos, we're going to have John Green, Aruba's Chief Technology Officer, join us with some guests to talk a little bit about what they see coming, not in the next year, but in the next 3 to 5 years, some of the big kind of game-changing technologies that are coming down the pipe. So let's kick it off, Miles. Let's go into that full stack demo.
Let's get it started. So what I'm going to try to do for you is we've been doing a lot of work in central monitoring over the last year. And I want to do a very rapid review, so it'll be a little bit of a flash up on screen here, but there's a lot to show. So let's dive right into Miami. As we start in Miami here, what you'll see is an overhauled health system that essentially ties alerts and health better together, helping administrators to understand better how health is derived. As we dive into one of my favorite alerts here in the alerting system, a DHCP alert, what you'll see is enhanced actions card that includes both the root cause and the prescriptive actions that one may need to take to be able to solve this problem. As we go down into the troubleshooting card, there's some really exciting stuff here, so I'll go ahead and expand it. As you can see, Central has already kicked off a bunch of different tests to ensure that the administrator, when they show up, have all the information available to them to be able to solve this problem quickly. Zooming back out to Miami, I'm going to go to the applications planet. As we look at the applications planet, it's nice to kind of look at things in more of a 7-day view, so I'm going to go ahead and zoom out there. And then I'm going to go look at maybe Facebook as an application and zoom in here. So what you'll see in our application performance tab is that we've added some cool things around end-to-end latency as well as client-to-gateway latency, giving me a full picture of where performance issues might be happening. As we go over to the UXI segment, what you'll see is we've added some more KPIs, as well as added measures around min and max, as well as extended the amount of time that we show UXI data in this part of the product. Coming over here to the clients planet, what I'll do is I'll go ahead and go back to 1 day, and I'll go ahead and look for a client that we named DIM. And as I drill into DIM, what you'll see here is something in the network planet that I think is pretty exciting, which is essentially the ability to drill into roaming events. As I highlight this particular set, you can see the different APs that DIM was on. You can kind of see what type of roams occurred, how long they occurred, as well as when it goes well, here's an OKC roam, and ultimately have a great place to understand overall how roaming is performing for that particular client. Now, there's so many other things, so much more telemetry that I could show you, but we really don't have time for it here on stage. So instead, what I'm going to do is go over here to the menu system, talk a little bit about all the extensions that we've added and partnerships that we've brought additional information into Central on, talk about our API gateway, in which now on our developer hub, we've got APIs for monitoring and configuration, talk a little bit about our KPIs that allows us to build more robust custom reports, and then finally our certificate management where we've enhanced things such that Classic Central users can import. Now, this just scratches the surface of the monitoring, but I wanted to make sure that we had time to be able to talk about something really exciting on the configuration side. So I brought Christina to stage, and I'm going to give her a little bit of a challenge here. The challenge is we've got an existing enterprise network. We've got to add an entire site. We've got to be able to have a CIC, some training center. There's 3 WLANs. There's VLANs involved. We got all types of stuff. So the challenge is in front of all these folks that we've got to do it in 5 or 6 minutes. Do you think you're up to the challenge?
Hey, Miles, challenge accepted.
All right, scoot on over.
So I've already pre-staged the network using the configuration library. Network services such as DNS, NTP, and the authentication server were identical across the network. So opposed to using the 3 separate workflows to configure the AP, switch, and gateway, I just used a single profile.
Awesome.
Yeah, so with that being said, let me show you. The authentication server required redundancy. So for the device function, I've assigned the gateway, the switch, and the access point using a single profile. If we take a look at the assigned scope, I've assigned the global scope. This is due to the standardized deployment model. Now let's take a dive within the profile. Within the profile, unified profiles have what's called device-specific parameters. These are parameters used to configure a specific device type. So for example, on a switch, I can assign an authentication server to the default, management, or the user-defined VRF. And then for the gateway, I can specify a call station ID type. That's pretty cool, right?
That is really cool.
Excellent. So at this stage, the system management and network services are pre-configured and deployed across the entire network. So we can actually dive into the VLAN and wireless SSID.
Yeah, so wait a second. This kind of seems like cheating because 60% of the network configuration is done before my 5-minute challenge even started.
Well, time is money, Miles,
All
so
right.
let's get started. We'll move forward to the library. We'll navigate to the VLAN category, and then we'll select named VLAN. Now here, if we take a look at the partner VLAN, just like the ops server, I was able to assign this profile both to the gateway and the access point. If we take a look at the assigned scope, you'll see that this profile is assigned to the London Campus Center only. I didn't necessarily need the partner VLAN across the entire organization. Now, if we take a look within the profile, I can specify the VLAN ID using 2 methods. I can either define it manually, or I can use what's called an alias. An alias is simply just a user-defined variable that can define configuration parameters. So for example, when I select the alias catalog here, the system will fetch all of the aliases within the library itself. So in this particular case, we'll just modify the VLAN ID to 445. Now, the library offers reusability. Now, with the reusability, we're able to see where and how many times I've actually used this profile. So currently, I'm reusing this profile within the AAA authentication profile, but I'm also reusing it within a wireless LAN profile. Wait, speaking of wireless LAN profiles, let's go ahead and get those deployed now.
We do have to get to that.
That we do. We'll navigate to the library category, navigate to wireless, and then we'll select WLAN. Now here, I've already pre-staged all of our wireless SSIDs, but there's something I like to call out different here. You'll notice that the device function and the scope columns are completely empty, but that's actually by design. The configuration library allows me to map profiles days, weeks, or even months in advance in preparation of day 1 or day 2 network changes. Now, before we deploy the actual configuration, let's just validate our config as a best practice. So, starting with step 1, I've enabled all 3 frequency bands to leverage multi-link operation for our new Wi-Fi 7 APs in the Campus Innovation Center. Then, should I need to fine-tune any of the settings, I can simply just select the advanced parameters and customize as needed. In step 2, I've set the key management to PSK. Oh, wow. I'm just moving along. You got me on this timer, Miles, so we got to keep it moving. But I've set the forwarding mode to tunnel. I've selected a pre-configured gateway cluster, and I've also selected a named VLAN. And now in step 3, since we're on this timer, Miles, I've set the key management to PSK. I've also selected MAC authentication, and then I'm reusing an auth server group. That auth server group is comprised of the 3 authentication servers that I utilized earlier during the pre-staging process. And then finally, in step 4, I've selected the partner VLAN from our central policy manager. So now that we validated our VLAN configuration, or wireless LAN configuration, let's move forward with deployment. I'll select Assign, select Mobility Access Point. Now, what's different about the training SSID, I don't necessarily need this SSID across the entire organization, but I don't need it across the entire London campus site. So in this particular situation, I'll just assign it to a set of APs within our Campus Innovation Center using a device group.
Okay.
So we'll select Device Group, select Campus Innovation Center, select Add, and then Assign.
So it looks like our 5-minute timer is about out here, Christina. So where are we?
Hey, Miles, we could have done this entire thing using API, but good thing I have a script on standby to take care of that.
All right.
We'll navigate over here to the Postman, where I've already defined a payload to automatically assign the remaining scopes to the hierarchy. I'll execute the API. Here, we're just waiting for the 200 OK, and that's what I like to see. We'll go ahead and refresh the page. And at this stage, I've assigned the guest SSID to our MEA site collection. I've assigned the IoT to the London campus site, and I've assigned the training SSID to our Campus Innovation Center. So that allowed me to leverage granular control using our multi-level hierarchy.
That's awesome. And if you didn't have to train me through it, I'm sure it would have gone much faster.
It would have gone much faster if I didn't have to train you through it. Hey, Miles, really quick. I was actually talking to a customer on the showroom floor, a data center customer in particular. He was mentioning he's having some difficulty with his topologies. He's using outdated diagrams. He's trying to reverse engineer. Would you happen to have anything that can help him?
I do. So we've got some exciting things that we pulled over from Classic Central. I'm going to show you, let me show you on this laptop right here. So as I dive into the Oakmead data center, one of the things that I'll kind of highlight here is something that actually already existed, which is our host and VM planet, where essentially we're pulling in information about the servers and hypervisors that are connected to this particular network. But we've already covered that in years past, so let me go ahead and fast forward over here to a different segment. Over here in topology, if you've been in Central lately, you'll be familiar with the sunburst visualization. But as a network engineer, you may be a little bit more familiar with a different visualization of how networks come together. Right here, we have something that we're calling the link node diagram. So this is something in which hopefully is familiar to most of you out there and ultimately represents a data center that we have deployed that's purpose-tuned for being able to train AI models. Over on the right side, we've got an ingest side of the network in which we've got CX10Ks, our policy-based switch platform, down along the leaf. And then we've got the 8360s in the top providing the spine. And then obviously we've got our ingest as well as our storage and server eating all the data from other networks. Over on the left-hand side, we have where the training is actually occurring. These are 9300s, and you can see really fat links between these with 400 gigs. Ultimately, what we wanted to be able to provide in this part of the product is the ability for network engineers to be able to lay out their networks as they understand them, logically in format. So what you're able to do here is you're able to grab any of these nodes, drag and drop them to what you want to, put them anywhere on the screen, and be able to ultimately have your view of how your network is laid out. So hopefully that's something really exciting for everybody out there that has to be in Central every single day. As we come back out here to the Oakmead data center, I'm going to drill into the security planet. Something else familiar to existing Central customers is the fact that we've got robust information around sessions. I'm just going to zoom out one more day, and then I'm going to go ahead and expand the sessions table here. And because we're in a data center, I'm going to go ahead and look for some Rocky flows, Rocky v2 specifically. As you can see here, I quickly pulled up all the different Rocky v2 flows. For those of you that may not be in the data center, Rocky v2 is a protocol that helps us to allow for low latency switching and attach that storage to the servers over IP networks and do it efficiently. Now, all these capabilities are something in which I'm highlighting today within the world of CX, but actually are applicable to our APs, gateways, and anything else. And you'll see this coming out in public clusters here in about 3 months. So really, really exciting stuff.
That's going to really help that customer, Miles.
Now, that customer may be in a situation in which they're saying, wait a second, I manage my data center on-prem. And that's why we've got an exciting announcement here as well, in which we're introducing the beta for our new Central on-prem. As you can see here, I'm in the system management pane in which I can drill into this 5-node cluster. Yay, really understand all the different kind of specs and elements of how it's performing. I can go into the maintenance and understand what version it's running, as well as provide upgrades and do a backups, restores, all types of cool things. So the net to understand about this, though, is that it's also really exciting because, again, it's not just for data centers. We're supporting AOS 10, we're supporting AOS CX, we're supporting AOS S here. So a lot of robust capabilities that match up with what we're doing in the public cloud.
That's amazing, Miles. And actually, you know, we still have a P5G demo to do. So I'm thinking, since you've challenged me to do a wireless LAN deployment in 5 minutes, I'm not going to challenge you.
Uh-oh, okay. So what Christina knows that the audience will probably love here is that from a time perspective, this is probably one of our riskiest demos. So I'm going to go ahead and kick something off before even explaining it. I have a ton of confidence that this thing is just going to hum and work the exact way we expect it to, but I wanted to start that and then explain what I was doing. So ultimately, what you saw me do here is come over to Stranger Thrones, kick off the deployment step. In the background of what's going on in the deploy is a lot of complicated things that for me, as a WLAN background engineer, ultimately are things that I don't understand in any way, shape, or form. But as I'm talking here, all of it's getting deployed and making sure that everything's good to go. Now, before this whole thing, I set up the Ted Banks network to give you a quick view of how simple it would be to bring up a core. As we go into the workflow here, it's as simple as setting a network name and a location. Everybody can do that. I reserve a set of VLANs that the cores are going to interact on. So if you know how to do VLANs, you got that part down. As we come into the configuration of the PLMN, you just have to do mobile country code and mobile network code, which are actually just lookups that you can find anywhere. And then as we come over to configure radios, I imagine this like the IPs that we set on our gateways or controllers, simply a way that our radios can talk back to our core. As you can see, simple as VLAN, subnet, and then declare a set of IPs to be assigned there. Coming over to the services, these are kind of like our networks, our SSIDs, if you want to imagine it that way. I give it a name, I give it a particular network that it's going to exit the core on, and then over on the right side, what I'm doing is assigning all the different parameters for those clients that will attach to that P5G network. I can also come down here and add a service if I so choose, but for the demo, we won't. And then what I've got is essentially the onboarding of these core devices. I have to go grab the serials off the boxes, paste them in here, easy to do as well. And that's it. I just went through the whole entire configuration of bringing up a new core for a private 5G network. So really exciting capability there.
That was simple and straightforward, Miles. But I see an HPE Discover 2025 there. Can you dive into that a little bit more?
I sure can. So while we're waiting just a little bit more time for this thing to deploy, I'm going to go ahead and drill into the HPE Discover network. So our TMEs have been hard at work, not only deploying our Wi-Fi 7 700 series enterprise WLAN network around here, which you all are attached to, but also deploying a P5G network to go along with it. So this is something really exciting. You can see quite a bit of traffic pumped through this, 78 gigs, as well as 3 gigs uplink, and all types of other information just giving me the overall health of the environment. If I click over here on radio statuses, I can get a quick view of what's going on with the radios.
Wow, Miles. So here's the thing. I've seen Wi-Fi 7 APs all over the place, but where exactly are these 5G radios?
Really good question. So up on the screen, you can see 3 different radios that we've got. For somebody over there, you might reach under your seat and find one of them. Please don't disconnect it. Over here in this area, in this general space, we've got the showcase, and there's 2 radios over there. Interesting thing about this, I was talking to Pragadesh, one of my good friends that have set up this entire thing, I'm sure with other folks, and he was telling me that they brought up the first radio here, and it actually covered enough that he could connect from anywhere in the Discover area. So
wow, that's
really exciting.
A lot of coverage.
Lot of coverage, and the 2 other were just added for the simple reason of making sure we've got more capacity. So coming over to the monitoring KPIs, again, robust information to be able to understand exactly what's happened in the last 3 hours, 6 hours, and so on and so forth. I could scroll down here, all types of graphs telling me what's going on. Service profiles, just for a quick learning moment here, is the ability to kind of like slice those particular networks into different segments, as well as provide some other service details. I do want to kind of show how clients connect if you want to use that language, right? So over here in the subscribers pane, you can see that we've got all types of clients. The first thing I do want to talk about, though, quickly is how we add a particular SIM or the identity in which these devices join the network. So if I come over here and look at single SIM, this is how I could just add one, or I come over and I do multiple SIMs, and I could upload them as a CSV. I also have all types of clients here in which are connected to the network, right? I've got cameras, I've got our BR150 bridge, which is essentially our way to be able to connect remote sites over 5G. I've got iPads, I've got even some of the attendees that have signed up to be connected to this. So really exciting capabilities across the board. Now, I noticed in this little pop-up,
I was wondering, Miles.
I know, I think we did it. So if I come over here, Stranger Thrones successfully deployed under 5 minutes. I think I met your challenge.
That you did. Excellent job, Miles.
All right, David.
Great. Thank you, Christina. Thank you, Miles. Great demos. Good to see the progress that we've made in the last year in terms of delivering an easy-to-use private 5G offering and filling out our full stack vision. Next up, we are going to move into the AIOps demo section. But first off, to provide some context, telemetry really is the lifeblood of AIOps. Today, Aruba Central has almost 6 million devices under management. Devices meaning APs, switches, gateways. And those devices are in turn connected to more than 3 billion clients, as in laptops, mobile phones, IoT devices. They're spread across more than 200,000 customer accounts. Every day, every minute, we are collecting telemetry about the performance of those 3 billion endpoints and about the operation of those 6 million devices. More than 1 trillion data points of telemetry a day. This data is collected, it's anonymized, and then fed into our central data lake. And that data lake is really what we use to be able to derive insights, to learn, and to come up with more effective ways of operating and optimizing networks. We have a team of more than 80 data scientists who are working at the forefront of machine learning and AI to harness this data. Together with HPE, we've generated more than 600 AI-related patents. Now, what is this data all about? It's very rich and diverse. The telemetry includes all kinds of things: performance metrics, data about firmware upgrades, reboots, authorization events, deep packet inspection results. The list goes on and on. Now, what do we use that data for? Well, there's many things, but a few big categories. One, we use it for service assurance. So we use it to measure, are we giving users the experience that they expect? And if they're not, we use that telemetry to help troubleshoot and remediate the situation. The second thing we use the data for is for optimization. optimizing the configuration of the network, tuning parameters to deliver better performance, better availability, lower cost. A third use of the data is around profiling devices, particularly IoT devices. In a zero-trust environment, it's really important to know who and what are connecting. When it's a person, you're usually authenticating them. They're logging in, so you're getting identification that way. For most IoT devices, they're headless. You can't do it that way. And so you need to be able to monitor and fingerprint to figure out what kind of a device is connected to your network, and then continuously monitor to make sure that the device is behaving in line with your assumption. If it's a video camera, video streaming's great. But if this thing is supposedly a temperature sensor, it shouldn't be streaming video. And so that's what we mean when we talk about device profiling. Now, our journey with Central and AI began almost a decade ago. And we first began bringing AI insights into Central in the year 2019. We've steadily built on that, as I said, with the service assurance, with optimization insights, and with the ability to profile devices and clients. With all of the hype in the last 2 years around generative AI, as you can imagine, of course, last year, we introduced natural language search based on Gen AI to make it easy for you to find answers to your questions and to interrogate the Aruba Network Central without having to know a lot about the UI or a lot of syntax. This year, obviously, everyone is talking about Agentic AI. And we are going to be showing here today our new Agentic Mesh AI-based capabilities. These allow you to do very fine-grained troubleshooting, very fine-grained root cause analysis, then remediation. And all of this is documented with a chain of thought. One of the big problems people have had in the last couple of years with advanced AI is understanding how the AI got to the recommendation that it does. It says, turn this off, and you go, why? It doesn't really have a way of backing that up. With Agentic AI, as you'll see in the demo, the multi-agent orchestrator provides a full chain of thought, like full documentation of all the things it's tried to basically verify its troubleshooting and root cause analysis. It does pro and con analysis of the remediation choices so that you can see exactly how it's thinking. Maybe you don't agree with it. Maybe you don't want to adopt the suggestion. It's a bit like if you have an extra member on your IT team and you delegate something to them, they come to you the next day. You may agree with their conclusions. You may have one or two things you want to tweak. But one way of thinking about Agentic AI is it's like having additional members on your IT team that work 24/7. While you're asleep, they are working and troubleshooting and finding ways to make your network better. So how does it work? Over on the left, you've got the network administrator talking to a networking copilot. This is a big kind of trillion parameter class LLM that you're probably relatively familiar with the idea of a copilot. It's conversational. It responds to prompts from the network administrator. The key thing, the most important piece of the Agentic AI mesh is what sits under that, the autonomous multi-agent orchestrator. This is another very large LLM. What's important about this LLM is that it's actually mesh connected to many other agents. So in our current implementation, more than 15 sub-agents. Some of them are real-time agents that are specialized in understanding and analyzing real-time data, like link health or application health or topology. And some of those agents are specialized in more kind of offline data or knowledge, things like our knowledge base or our bug database. Anyway, the multi-agent orchestrator can draw on all of these other agents in order to do things. It's a reasoning agent, so it's able to think through things and come up with steps, but it doesn't come up with steps and tell, hey, you need to do these steps. It actually starts taking action. It's a reasoning action model. So we'll go through, take those steps, collect the results, and come to conclusions. So super exciting. I could keep talking about this because I'm really, really excited. I think generative AI, maybe I was a little bit of a skeptic about how big that could be, but agentic AI can really make a huge difference for the way that we do AIOps. So Miles, I think I'll give it to you at this point.
Yep.
Can you show us a demo?
Yeah, so we've got a nice demo here. So let's go over another 2-minute review of some exciting things that happened in the platform in the last year. Again, I'll have to move really quick to get through them, and then we'll go to the next demo. So as I dive right in here, we've added over a dozen new insights into this panel over the last year, as well as made 30 enhancements across the others. I'm only going to have time for 2. So the first one I'm going to go to is the spanning tree anomaly recommender. As I dive into Bangalore here, what you'll see is a dashboard that kind of shows me the idea of what topology change notifications have happened in the network and recognizes when there's an anomalous number of them. Now, the recommendations that it can make out of this are 3. Number 1, you can have a recommendation that essentially says, I, Central, understand what your core and aggregation is. You should probably move the root bridge up to that particular device. Number 2, I understand when I've not have BPDU guard assigned at the edge, and I should probably assign that. Or number 3, I generally understand what the topology is, and you've got some odd configuration in terms of how you've set those priorities. Now, as you can see in this particular instance, right, we're making a recommendation to enable root guard on a port that Central has recognized as facing clients, and we've probably got some spanning tree events that should be coming in from there. As you can see, other creature comforts as well, a really good view to be able to understand where these events are coming from and their trend, as well as dive into the topology. I'm going to go into my second one, which is the coverage hole optimizer. Here in Indianapolis, you can see a really good picture of all the different access points, clients, and the number of minutes that have been impacted by possible coverage holes. As I scroll down, you can also see that we've got a nice graph indicating to us for the poor coverage hole APs, as well as for the more well-performing, what is the overall SNR coverage, what's the uplink SNR coverage, and what's the downlink. As I scroll down finally, right, if I just need what the prescriptive action is, I actually get that right here in this list. For AP1, I have no option but to add an AP to get some additional coverage. And then in AP4, I'm just adjusting power levels and air match to be able to appropriately fill in for that gap. Now, again, this just covers what we've done in Insights, but we've been doing exciting things in the world of Gen AI as well. Up here in the search bar, what we're able to do is do something as simple as show me Windows wired clients and hit enter. And essentially what's going on in the background is there's an LLM that's understanding the intent of what my search was. And then what's happening is it's returning all those results. As an administrator, I didn't have to understand a syntax or some particular way to write this query to get it to show up for me. So that really covers, in as close as I could get to 2 minutes, what we've done in the traditional AI and Gen AI space. But what I'm really excited about is the agentic AI piece. I've invited Divya to stage to show us some of that. Divya?
Thanks, Miles. So excited to be here presenting a live demo for Agentic AI. Let me show you what we have. So this is Central Copilot. We are going to start with user-driven workflow of communicating with autonomous orchestrator. Let's ask a complex question that requires to join multiple data sources. So I saw some of the gateways joined a cluster at Roseville site. Let's ask for the list of these gateways, and maybe throw a connectivity path in there as well. Path for the latest one. I definitely made some spelling mistakes there. I'm sure LLM will understand.
Based on our rehearsals, I'm sure it will. So what's going on in the background is essentially this has kicked off an engine that's parsing down what Divya's request was and what she was asking for. It's then using the reasoning to kind of determine what agents it needs to talk to across Central. These agents, sub-agents really, are the things like understanding what a site is, understanding that Roseville is one of those sites, understanding gateways and the idea of clusters, understanding that to get something like a connectivity path, it has to start to go dive into that gateway, extract what the different wired interfaces are, maybe stitch them to other devices in the network, and then pull all that information back into the reasoning agent so that the reasoning agent can put it together and start to form a really sensible output for Divya to be able to take her next action. This is something in which all of that stuff is then formed into UIs that essentially help the user in whatever their next step is going to be. So I think we've got some really good output here. Do you think we can go through it here?
Yes, of course. So in a few seconds, it took a complex question, understood the context, joined different data sources, and generated an output. The output consists of multi-parts. First is the text-based response. OK, so first is the text-based response. Here we get a quick summary like the gateway name. Then we have is the detailed breakdown, like the status, health, role, cluster it has joined. We also have the connectivity path and the wired interface that is used to connect to the Core 1 switch. Next is the device table. This is where you get the second-level information about the gateway. And you can do all the good things like sort, filter, search, customize the columns, and even export this data. Last but not the least is the visualization for the connectivity path, as I asked. Our orchestrator also creates follow-up questions based on my initial query. So let's also ask for the usage trends here. OK, so in a few seconds, it has taken all the information and gave me an output. I have not gone to a single screen within the dashboard. And moreover, unlike any other product in the market, we are using the same UI components that you are used to seeing in Aruba Central, so there is no learning curve as well.
That's right. So David talked about kind of two different models in terms of interacting with this Copilot. Number one, the one where the human is steering, and then number one, where it's autonomously being kicked off in the background. Do you think we can see that?
Yes, of course. So orchestrator can run autonomously. And whenever it identifies any issue, it is raised as a part of agentic mesh actions. Let's look at this roaming issue to find more details.
Now, this one is coming really, really quick, which may seem like we're just faking it or something. But the reality is that reasoning that we were doing before actually already occurred because it was autonomously kicked off. And then all we're really doing is seeing the output here.
You are absolutely correct, Miles. So roaming has been one of the hardest problems to solve in the Wi-Fi world. And we have worked harder to make it simpler for you. We already have a roaming insight that is based off prescriptive AI. So it runs at regular intervals, checks certain conditions to give a roaming recommendation. Agentic AI is a game changer because it can run in real time, and it can do its own reasoning and thinking. So it is definitely doing much more than just checking the set conditions. Now let's look at the output. The first thing you see here is the issue breakdown. So I know that this issue is impacting my Bangalore site, and it has affected 46 of our clients. Next, we have is the root cause. The orchestrator knows about your network configuration. And here, it is comparing your network configuration with device capability. So I know that we have enabled 11R on our WLAN profile, but the clients are not 11R compatible. Let's move on to the remediation.
Wait a second. So remediation, that's great, but let's show a little bit about how we can trust that this remediation is actually what we should be doing.
Well, of course, I have some data for you.
All right.
So looking at this graph and the table, I can see that the clients are impacted during FT-roam, and these FT-roam map one-to-one with the PMK failures. Now, this table gives me more information about the client devices. Our orchestrator is leveraging our locally trained LLM models to predict information like OS and model. Then this information is used to find the device capability, 11R compatibility in our case, using our rich client knowledge base. So I know that the devices are not 11R compatible, They are trying to do an FT roam and are failing in a process during authentication. Now let's go back to the remediation.
Let's.
So the orchestrator acts as a subject matter expert, and it is coming up with different possible solutions. It's looking at their pros, cons, and trade-offs. It is suggesting that we can disable 11R temporarily to resolve this issue, but a better solution is to create a separate WLAN profile with 11R enabled for the compatible devices. Now, I have an option to disable 11R temporarily from here itself. I can do it immediately or at a later scheduled date. Let's schedule it for a later date for now. Perfect. So as we saw, the orchestrator is not working in silo. In fact, it is reasoning and thinking and correlating different data points. It is looking at roam failures, auth failures, client stickiness, coverage holes, client capabilities, percentage failures, time series data, just to name a few. It would have taken you at least a couple hours, if not few days, to come to this conclusion. And the orchestrator did it on your behalf without even asking a single question. Pretty powerful, right?
Really powerful. So hopefully this shows AI capabilities across the platform. Really exciting stuff. So David, what do you think? Backstage there somewhere.
Hey.
Hey, David.
That's great. Thank you so much, Divya and Miles. I think that next up we've got the security demos. But what we've been seeing over the last few decades is the co-evolution of networking and security. The two are becoming more interdependent, more interrelated. In the 1980s, when the internet was kind of first invented, it was an any-to-any network where a professor at one university could access the server of a professor on the other side of the planet. Obviously, as the technology was commercialized, the firewall was invented so that corporations could leverage the internet but keep the bad guys out and protect the good stuff inside. It didn't take long to realize that there's ways of bad things getting inside the castle, on the wrong side of the moat. So a bad virus could come in on a laptop, or someone could get infected on the inside just by going to the wrong website. And so it became necessary to not just have firewalls around the perimeter, but also to chop up the inside of the network into segments to contain the blast radius of any kind of breach. Right now, we're kind of at peak firewall. We've got so much segmentation going on, so many firewalls to manage. It's very brittle and very complicated. And so in the last few years, that's really forced a rethink of how networking and security can work together. And there's a lot of buzz around zero trust, but zero trust principles are actually essential to kind of break through this problem of peak firewall. We need to be able to rethink the problem. Essentially, what zero trust is all about is, rather than starting with an any-to-any network and then taking connectivity away, it's more about starting with default deny. Nothing connects to anything, and then we have policy which decides who can connect to what. So if we look at the problem, on the one side, the job we've got to get done is we've got people and things on the left, and they want to get access to certain data and applications. So we need to identify those people. So identity is very important. We need to be able to identify the devices. So as we talked about, the profiling, the AI-based profiling to classify devices is important. Once we know what's connecting, our global policy tells us what it's allowed to connect to, what data is available to it, what applications are available, what services are appropriate. We want this policy to be global in the sense that it shouldn't matter where the user is. It should work whether they're at home or on the road or in the office. Similarly, it shouldn't matter how they're getting on the network, whether it's via public 5G or private 5G or wireless or wired. Then, we want to be able to enforce that policy at the most appropriate point. So if it's a IoT device, a thing that's sitting in a factory, we really want to be able to constrain the connectivity on-prem in the factory. We don't want to have that data going all the way out to the cloud and back. So edge enforcement in APs and switches and gateways is an essential part of our architecture. But for other use cases, like a user working from home, there is no enterprise equipment in the path between the user and the SaaS service that they're using. And that's where cloud enforcement is important with SSE capabilities like CASB, SWIG, and ZTNA. What we're doing at Aruba is bringing together the best pieces of SSE with on-prem capabilities like IoT device identification and continuous monitoring, and a modern NAC infrastructure so that we have zero trust, not just for people accessing apps, but for things accessing services and data. So at this point, I'm going to ask Miles to take us through a few of these demos of new capabilities we have in our zero trust and security portfolio. Thank you. Miles.
Let's dive right in here. So last year, we introduced you to something called Central NAC. If I go over here into the Central NAC dashboard, I'll go to configuration, just remind you of some of the horsepower that we have here. We can set up authentication profiles, authorization policies, and identity management to create an identity policy from the cloud really simply. Over this last year, what we introduced is a local visitor database, integration to messaging platforms such that we could onboard guests easily, as well as portal customization. Now, when you guys come to Discover, you're not looking to look back, you're looking to look forward. So let's go ahead and dive into some of the new things that we're showing off. If we go over here into the summary and drive down, oh, I'm sorry. To do this, I've invited my buddy Adam over here. Surprise. Adam is going to help me out a little bit in telling how the Central NAC story attaches into our SASE story. So excited to have you here, Adam.
Yes, sir. Glad to be here.
All right. So what I'm going to show Adam here is how we can dive into clients and go ahead and go to his user. This is why I remembered that Adam was coming up on stage. So if I come over here, what I'll show Adam is that from an authentication perspective, I've got his client backstage authenticated with ETLS. Coming over to authorization, I'm pulling group information from Entra ID, in this case VIP employee, to be able to get that aspect. And then if I come down here to classification, what you'll see is a few pills down at the bottom. I'll highlight those. CrowdStrike compliant, Intune compliant, Intune supervised, and MS Defender no risk. So ultimately, this is a really good idea of all the different aspects of authentication.
Yeah, so I guess the question might be, where do those classifications come from? Derived, manually created?
Good question, good question. So I'll answer it, just give me a hot second. As much as I love you, Adam, I'm sorry you're not a VIP. Maybe that's why I forgot you were coming up on stage. But ultimately, I'm going to ask my backstage partner here to change out that Entra ID group, and we'll come back to this later for my audience. So let me go ahead and show Adam here where our extensions are and show him what we've done in the area of being able to pull in those security tags and that additional context. Ultimately, what we're able to do here is use information from tools like CrowdStrike, as well as Intune and a bunch of others, EDRs, UEMs, as well as SIMs, to provide better context for what that identity can be. So really exciting capability to have a fully robust posture as well as other identity elements added to a user.
Unmanaged IoT devices, what about those guys?
Yeah, those are a little bit of a different equation here. So if I come back to Central NAC, and I go down to the clients, and I go to IoT, what I can see here is an IoT client that's been authenticated via MPSK, right? Pretty common for most enterprises. But what may not be common in all deployments is this idea of classification. You can see that this IoT tag down here has the little icon indicating that it was automatically assigned, and that ultimately now I can use some of that information as well as the authentication MPSK to be able to give it its identity.
Yes, and of course the question you have to ask is what happens if behavior changes over time or if it gets hacked?
Yeah. Those IoT clients can be quite hairy sometimes. So if I come over here to Mexico, and I go ahead and I look at this Insights tab, we've got something really exciting that we've added in the last year. And essentially, this is an anomaly detection called new country upload using suspicious protocols. If I drill in on it, what I'll quickly see here is that for this particular client, all of a sudden, it started talking in North Korea via FTP, so we might have an issue on our hands.
Yes, so now what?
Yeah,
what
so
now?
Really good question as well. Let's go ahead and go back to that client in the client list and changing up what I want to do with that client is as easy as coming over here, creating a tag, saying something like quarantine, if I could type, being able to come down here and then go ahead and set an attribute. There's a bunch of different attributes, but for now I'm just going to go ahead and say FTP to indicate the application. I could put that the destination was North Korea and a bunch of other things, but for the sake of the demo, we'll leave it here. And now I simply create. Now that tag is going to look for any other Blink camera that has similar traffic profile, the FTP going out, and be able to assign that tag. And I can provide enforcement with my WLAN, my switch, and even my Edge Connect to be able to block all that traffic, get it locked down, and make sure that I don't have any more spread of what's going on there. So really exciting. Now, let's go back to your user here and see what's going on. So if I go back to Central NAC and search for Adam, what you'll notice here is that Adam has been reassigned a user group, and therefore his role has been assigned to employee. So downgraded from VIP, I'm sorry. Now, most of the audience is probably asking themselves out there, well, wait a second, didn't Miles just do a change of authorization demo in front of the Discover stage? And the exciting part of this is not that I've done change of authorization, but I showed robust context around identity, I showed the CAOA, and I all did it against a Cisco wired device. So essentially, our cloud NAC-based platform is able to provide authentication identity for third-party devices. The way that we do this, yes, woo! I see Madani down there.
Yeah, I see you.
So ultimately, the way this works is that the Cisco switch sends a radius up to the gateway. The gateway sends RadSec up to Central NAC and then provides all the robust capabilities that you just saw across the platform. So really, really exciting. And by the way, it pairs very, very nicely with our third-party observability story that we leverage OpsRamp in Central to be able to monitor Cisco switches as well as a bunch of other things. So we're really excited about what Central NAC is going to provide for customers, whether you're using Cisco, whether they're using Palo Alto, or any other device that can speak radius. But this just solves the problem for the LAN side, right? We need to start moving outside the LAN, go to the edge, and even beyond. So again, Adam, let's talk a little bit about how we can use that role in the land of SASE.
That's right. So now we're going to talk a little bit about how we can bring the roles to the edge. So let me show you. All right, so a couple things here to start with. We're going to be launching the Edge Connect Orchestrator from GreenLake. So the orchestrator is now an app tile. That means that gives us single sign-on, it gives us RBAC, it brings the Edge Connect closer to GreenLake and HPE products. All right, so notice that we've landed on what looks like a new UI. So the orchestrator, the Edge Connect Orchestrator, has been refreshed, updated, modernized. It's faster, it's more accessible, and it's just more beautiful. Let's talk about a use case in which we can use the employee role in a way that will, I'm going to restore a little bit of access that you took away.
Bring back that VIP.
That's right. So look down here. This is our zone firewall policy intersection. We've got a from LAN, and we've got a from to WAN. And we're going to look at this intersection here. Notice that by default, for all of our flows, for all of our users, we're denying access to generative AI websites. Let's say that I want to punch a hole in that policy and explicitly allow or surgically allow employee role to access the generative AI website category. All I have to do is come in here, do an add rule, modify my match criteria. I'm going to first select the web category, generative AI. It's worth noting that what you're seeing here is making use of the IP reputation and web URL classification technology coming to the Edge Connect later this summer. So I've selected generative AI. I'm going to hit done. And we're going to come in here and select role and go to employee. We're not using IPs, VLANs, subnets, none of that stuff. It's role and web category. Now we hit done. Let's enable this rule. It's set to allow. Done one more time. Done. And now we're going to hit save. When we hit save, this is a globally scoped firewall policy. Will be pushed to 10, 100, 1,000, 5,000 Edge Connects. Will now receive this policy that will allow employees to access generative AI websites.
That's awesome. So now we've got how we can use that role to create an enforcement role on the Edge Connect. But what about all those customers that are starting to leverage SSE to do other policies using some of that stuff? What can we do there?
That's good use case. So SD-WANs, in particular, the Edge Connect, very good at steering traffic, deciding for a particular kind of traffic, how should you route it? Should you send it to local breakout, which would be directly to the internet? Should we backhaul the traffic to a data center? Or in this particular case, we're going to route our generative AI traffic across an SSE tunnel to our secure web gateway service that's a part of the HPE SSE offering. All we have to do to invoke that use case here, go into our business intent overlay. Notice that HPE SSE Cloud is the very first policy in our SSE overlay here. All we have to do is modify this access list. I've pre-populated it. We're going to match generative AI. We're going to match our employee role. This will cause that traffic to be steered toward the HPE SSE service. You might say, why would we do this? Well, we'll get additional filtering, additional logging. We can rip that SSL apart, look inside the payload. We can also throw a EULA at the customer or the user to say, hey, it's generative AI website. Don't be putting private or proprietary company information in these public generative AI websites. Makes it easy to steer and manage where the traffic is routed to. Now, the enabler for this, what makes this work at scale, is something we introduced last year, which is the complete automation and orchestration of secure web gateway tunnels from all of your Edge Connect gateways to the closest HPE SSE POP.
Yeah, so that's really exciting, and it solves the problem of how do we do some policy from the inside network to the outside network. But what about those contractors, remote workers, others that we might want to bring to the applications in the enterprise?
So Miles, that's the big thing that we're adding this year. Notice this tab up here. We've got Secure Web Gateway, but now we've added SSE Connector. This feature, this capability, brings the HPE SSE Connector to all Edge Connects. Whether you have a physical or a virtual Edge Connect, a virtual Edge Connect in AWS, a physical Edge Connect at your branch or your data center, all Edge Connects are now equipped with an HPE SSE Connector. This fulfills the ZTNA use case. It brings private enterprise applications, provides surgical access for users or contractors to those internal private applications, and more importantly, it removes the need for compute or additional infrastructure at the branch or the data center or the campus. The Edge Connect is the SSE enabler. We are making SSE, or we're making ZTNA use cases easy.
That's right. So for any Edge Connect customer that's out there, they could basically adopt this tomorrow very, very easily. Now, we went through this whole entire demo, and we probably only said AI 2 times, Gen AI, but I'm sure that there's something else that we can do with AI here on the Edge Connect side.
Yes, Miles. For a lot of people, this is the most exciting part. We're bringing a co-pilot to our SASE solution. Let me introduce you guys to the SASE co-pilot. This co-pilot understands SD-WAN. It understands SSE. It can help you write API calls into the orchestrator, so day 0 stuff. It helps you understand and configure your SD-WAN or your SSE configuration. But probably most importantly, it's really good for day 2 operations. So we've asked it, what's the network status? The co-pilot will go out. It will look through your fabric. It'll figure out what alarms are active. And in this case, it's returned a response that says, the network is up but degraded. Atlanta 01 has one of its 2 internet connections that's in a down state. So we can follow this up. Let's say, are any users with the employee role impacted? That's pretty cool because the SASE Copilot knows about things like overlays. It knows about flows and SD-WAN, but it also knows about roles. So you can directly query the SASE Copilot and ask it questions like, all right, there was an outage at the Atlanta office. Are any of the users impacted? It knows how to do that. It looks at the flows in this case. You can see that we've got 83 flows that match the employee role, and those flows have an average latency of about 10 milliseconds. Also, there are no security drops or blocked connections, so we can deduce from this that even though one of our 2 internet connections is down at our Atlanta office, users are not impacted.
Really cool. A lot of capabilities, even across day 0, day 1 activities for deployment. So that tells a really good story of how we're bringing Zero Trust together with central NAC, as well as our SASE, to be able to provide robust Zero Trust policy. David?
Great work, guys. Thank you both.
Thank you, David.
It's really exciting to see how we're bringing together our NAC and SASE offerings into a universal Zero Trust network architecture that is able to enforce policy for both people and things. Anyway, as I said, we are going to have a bonus section today. We're done with the demos, but next up, I'm going to invite John Green, our Chief Technology and Security Officer for HPE Aruba Networking, to join us along with a few special guests. John? Thank you.
All right. Good morning, Discover. I almost slipped up and said good morning, Atmosphere. Old habits die hard. Okay. So you would forgive me if I slipped up in that way. We're going to do something we haven't done before at this event. So for my 20-something years being part of this event, we've always used this session to really talk about products, things that we have just released or things that are just right around the corner. I wanted to do something a little bit different this year and talk a little bit about futures and technologies that I think are going to have an impact on networking, but maybe not this year, in 2 to 5 years. And really my goal was just to signal to all of you, these are areas you might want to look out at, you might want to be prepared for, and have an opinion, be smart about these types of technologies so when it comes up, you're ready to go. So we're going to talk today about 3 topics. We're going to talk about quantum computing and its impact on networking. We're going to talk about silicon photonics and co-packaged optics. And of course, we're going to talk about AI. And to do that, I've got 3 guests who are going to join me on stage who are much smarter than I am. So I'm going to ask them questions and get their help. For the first one, I would like to welcome out Grace Johnson from HPE Labs. Grace, thank you for joining us. Have a seat.
Thanks for having me.
We get to take it easy up here. So you're sort of a relatively new PhD grad from an obscure school nobody's heard of called Stanford. When you're not on stage at Discover, what's your day job, and how did you come about coming to HPE?
Yeah, so after I finished my PhD in quantum chemistry, I was excited to join labs to work on how to build a quantum supercomputer. So to reach real-world applications of quantum computing, things like simulating chemistry, we'll need to scale from hundreds of qubits, which is where we are today, to millions. And we think a big part of this is integrating quantum with classical HPC.
So you said qubits. If I put this into basic terms, and obviously we don't have time to do a super deep dive on this today, and this breaks my brain hurt anyway. A digital computer that we're all familiar with is kind of based on the idea of binary zeros and ones. And a qubit, as I understand it, can be a 0, it can be a 1, or it could be something in between. Is that sort of on track?
Yeah, definitely. So you're describing one of the fundamental properties of the quantum realm, something that's counterintuitive, right? Somehow Schrodinger's cat is both dead and alive. This is something called superposition, where a quantum particle can exist in multiple states at once. The other strange property of quantum mechanics is entanglement. So if 2 qubits are entangled, it means that actions on one will affect the other, no matter how far apart in space they are. So for quantum computing, if we can sort of harness those 2 properties, we can reach a very large computational space, a space that is and will always be beyond the reach of classical computing, even supercomputing. So this has major implications for applications like drug discovery, materials design, and cybersecurity, because a good enough quantum computer could break RSA encryption.
Yeah. If I do a Google search for quantum computer, I get this crazy sci-fi looking round thing that I've learned from you is called a dilution refrigerator.
Yeah.
Never heard that word before. is our audience going to have a data center full of these crazy looking things, or is it going to be huge? How does it take up a room? What is this going to look like?
Yeah, so it depends on the type of quantum computer we have. There are many different kinds. The dilution refrigerators here are used for certain kinds of quantum computers to keep them very cold, almost near absolute zero, to preserve those delicate properties of superposition and entanglement. But a major challenge, I mentioned we need to get to 1 million qubits, is how to scale up, right? So we think that these quantum computers will act more as specialized accelerators, we can call them QPUs, that are tightly integrated within HPC infrastructures. But the QPUs will be limited in size at some point. So in order to scale out, we will need to network many of them together within a data center.
So these networks, is this going to be kind of Ethernet and Wi-Fi like we're used to, or is this something brand new that we've never seen before?
Yeah, we think we'll need both classical and quantum networking. So certainly quantum networks so that we can entangle qubits across QPUs. This will be probably optical or microwave interconnects. But we also know that quantum algorithms rely on lots of classical co-processing. So we'll need HPC interconnects as well. And in fact, at Labs, we're working on algorithms for distributed quantum computing using only classical communication.
Okay. You mentioned before breaking RSA encryption, and probably a lot of people in the room have heard about that already, because for us in networking, it's a threat to us right now.
Right.
But quantum actually enables better security, and there's some new opportunities for new types of encryption. Can you talk to them about that a little bit?
Right, yeah, so a major task in cryptography is key distribution, right? Basically making sure two parties can share a key without a third party eavesdropping. So classical computers do this with schemes like RSA, but with quantum key distribution, we would rely on another fundamental property of quantum mechanics, which is that if you interact with a quantum system, you actually destroy it. This is called collapsing the wave function. So as a simple example, if I wanted to share a key with John, I would prepare a quantum state, either 0 or 1. I would send it to him. He would measure it. And if our results are different, we know that somebody has eavesdropped because the process of their eavesdropping actually changed the quantum state.
Very cool. I feel like I now have PhD level knowledge in quantum.
Nice.
Thank you for that. If people want to learn more about this, where can they go at Discover?
Yeah, visit us at the Innovation Campus. We have a demo booth on quantum supercomputing, as well as the breakout session on quantum cryptography.
Awesome, thank you. Can you hang around for a little bit?
Yeah.
We'll bring up our next guest to talk about optics. So next guest is going to be Kirk Bresniker, also from HPE Labs. Kirk? So you don't really need an introduction. If anybody who's been around these events knows you from years back. So thanks for joining us here. I've got a couple of quotes we're going to put up on the screen here that I found that are kind of interesting, and I think these are data center type of applications they're talking about. But one of them is really about, in the context of AI training, networks being the bottleneck to rapid training. And the other one is really from Jensen Huang this year, talking about power consumption of just going from electrical to optical back to electrical, and how much of that on an AI factory scale we're consuming. And so this idea of silicon photonics and co-packaged optics has been proposed as a solution to those particular problems. I guess my first question is, what are those technologies? Are they the same thing, or are they different?
Yeah, well, let's unpack that from the inside out, and then we'll look from the outside back in. First, photonics. Photonics is our ability to engineer systems that capitalize on the unique properties of the photon, both the classical and the quantum mechanical, to do useful work, to do sensing, to do communications, to do computation. Now, silicon photonics is where we utilized our skill and economies of scale. You know, I didn't grow up in the gallium arsenide valley. I grew up in the Silicon Valley, and that means that is the technology, those techniques of lithography and manufacturing, and we want to utilize those in order to produce our photonic systems. And we do that not only for economies of scale, but for interoperability and freedom of design. I want to commingle electronics and photonics, and I can do that in an integrated circuit But what I also want to understand is that last piece, which is co-packaging. Now, when we think about those photonic systems, we want to understand how they are different. And frankly, when we think about designing communications with electrons, we have to worry about interference, crosstalk, EMI, RFI, shielding, resistive loss. None of that happens with the photon. That's one of those unique superpowers of the photon. I can travel any distance for the same amount of energy. The other thing we can do with the photon is that we can take and stack and stack and stack. I can put 10, 100, maybe even more colors of light down one waveguide, whether that's on a chip or across a fiber, and they all can be operated independently, so that design freedom we have. And when we take that and we co-package, we want to say, I want to have my great VLSI design, and whether that is a switch or a NIC, and just like we do with GPUs, can I co-package? Can I put a GPU right next to some high bandwidth memory? Well, now I want to know, next to that high bandwidth memory, can I also put a silicon photonic optical electrical engine and get that design freedom? So right out of the switch, right out of the NIC, can I go immediately to photons? And when we think about it, this networking crowd, I'm sure a lot of you have plugged in those QSFPs either into a bulkhead or the faceplate of a switch. We want to have that same opportunity, but have it go all the way back into the VLSI.
So we should think about a chip on a board of a switch, for example, in which some of the processing in that stays in the optical domain, and then think about fiber optic cables kind of coming directly out of the chip?
Directly out of the chip, yeah.
Okay. And you've talked about it a little bit, but can you go into some more of what problems this is solving and what the benefits are?
Yeah, so whenever we think about communicating, the question is always going to be, how many bits over what distance, and then how much time, energy, and money are you willing to spend to achieve that with high reliability? And so when we think about this, we know, and we can do the math, and you are giving your customers that freedom of choice with the pluggable modules. If I'm going over a couple meters at top-end data center speeds, I'm going to choose a photonic interconnect, and it might be hidden inside of an active optical cable. What we're seeing now, though, is when we pull that photonics and co-package it right next to that VLSI, whether it's chip, switch, or NIC, we can open up new topologies, new architectures that simply could not be realized with electronics. And that's where you see the answers to some of those questions. Now, we pioneered a lot of this technology when we were building up the exascale systems, but then, given the advances in GPUs and CPUs and high bandwidth memories, we actually didn't need to flex that muscle. But now with these new advents of these new gigawatt AI factories, this could be the economic moment where we need to understand how we'll pull that technology in. And the great thing is for all of you and all of us is that we've done the work at labs so it's ready to be integrated into your products.
Yeah, so labs and you personally have had a long history in this area. We've produced a lot of the pioneers in the industry today, have gone through HPE Labs. What are we doing specifically to improve the technology?
Yeah, so for our work at Labs is all about making those design tools and design kits available. We've been working for a long time on the micro-ring resonators, the diffraction coupling grators, the silicon avalanche photodiode, the Mach-Zehnder interferometers, all these great pieces of photonic integrated circuit technology. Now, this is just an open acknowledgement. Innovation is a team sport, it's a global sport, and sometimes the best way to get Labs technology into an Aruba product is actually for us to establish it out in the open so that not only you, but all of your silicon partners can equally participate in these technologies. So we're working hard on making that available to all of you.
Awesome. This piece of our session is kind of about quantum and photonics and AI. Is there a grand unified theory for how these things fit together?
One of the things that's, I was just having a conversation with one of our labs researchers here this week with us in Las Vegas, and we were talking about, we're talking all about photonics here and transmitting classical information, and sometime in the future, will we be able to transmit quantum state between the QPUs that you're working on? So that's farther out. A little closer to home, though, if we think about AI and we think about inferencing, the heart of inferencing is linear algebra. And it turns out photons can do linear algebra as well as GPUs. And so if we add in one more piece of labs research, and that is the memristor, we have everything that's necessary to do what we're looking at as a super low latency, super low energy inferencing engine. Just like what you might want to put in the head of a drone, or maybe in that next Aruba access point to push high performance AI inferencing all the way out to the edge, right where that data is living and breathing. We look then, the next step beyond that is we look to repurpose some of these communications elements of the integrated photonics integrated circuit into computation, and we look at our quantum-inspired classical physics-based accelerators. What they are promising is to do some of the same problems that we look for quantum as a parallel solve, including the traveling salesman problem, NP hard solver problems, which will be fantastic for logistics problems in enterprise. It also, although, opens up the possibility of deep deductive reasoning to complement the LLM inductive reasoning. So deep enterprise reasoning thought driven by photonic computation.
Awesome. You're on the showcase floor if people want to learn more.
Absolutely.
You mentioned linear algebra, and I'm going to ask a question to our next guest about that topic. Please welcome out Jose Tellado. So, Jose, also Stanford PhD. I'm going to guess you were not there at the same time as Grace.
No, I didn't. You don't need an agentic mesh for that.
Okay.
But we did both take Stephen Boyd's class. So.
Yes, we took some classes.
Okay. The audience may not know you, but they've seen your work because you and your team are kind of the brains behind all of the AI, the agentic AI, all of that's been shown here on stage. So I didn't want to talk with you about products so much, but I wanted to ask you kind of about AI in general and kind of some topics that the audience may be struggling with. I think it's pretty clear that we're in a hype wave on AI, and we've seen hype waves going back to the 1950s. This one feels different to me, both on the amount of investment going into it and the amount of excitement in the general public for it. Since kind of the release of ChatGPT, which is, what, 2 years ago, how has your team kept up with just the pace? Because it's overwhelming to me.
So we have been in the AI for networking use case for about 10 years now. The first 8 years of those were classic AI techniques, workflow-based, business logic wrapped around models. The last 2 years is a roller coaster. It's not a journey anymore. But you have to be able to focus on what your use case is, figure out where your strengths are, and not chase the latest and greatest model or the latest and greatest tool, because you'll be stuck waiting for the next thing and not make any progress. So what you saw today, earlier today, was developed in about 3 to 4 months. And it's because it's commit and go. You basically have to figure out what is good enough and just go for it.
Okay. I'm fully ready to admit I have trust issues when it comes to AI. I'm cool with what you guys did on AI Insights, and as a recommender, I'm okay with a co-pilot that helps me sort of troubleshoot and pulls in information. I'm really a lot less comfortable with autonomy and with saying, hey, AI agent, go out and make changes to my network or operate things without me being involved. And so I guess the question up on it's a little bit different than what's on the screen. Not about how to make AI more trustworthy. How do I, as a network administrator, become more comfortable with trusting the AI?
So far, the first 8 years, we had classical AI techniques, and we would provide feature importance, statistics, confidence. And I do get that question from the field and the customers that they have trust issues because we're providing metrics from our models that are trained on their peers, anonymized, of course. But now, as you saw earlier today, we're throwing in reasoning models on top of our classic AI. So in addition to giving you metrics, it will give you the reasons why we made that recommendations. But if you still have trust issues, and I know a lot of people still do, start small. Within our suite of roughly 50 use cases, some are lower risk because they go after single devices, single clients, single SSID, single VLAN. So you could start there. Things you could do if you want to be a little more brave is go for configurations that will change or optimize your network in a bigger frame, but set it up in the middle of the night or on your weekends. And of course, we have real-time autonomous agents watching your network 24/7. So if you put in a Sunday night and something happens, we'll alert you before you get to work.
Yeah.
So yes, just start small, make sure that and by the way, as I said, in the 50 use cases, most right now are human in the middle, human in the loop. So we make a recommendation, we give you a chain of thought, we give you all the data, you can still review it and decide to go or not.
I guess one of the reasons I have trust issues is not fully understanding how the technology works. And so, for the past 2 years, I've been trying to get smart on that. I've read academic papers, things like that. And I quickly realized that the math is over my head. I've forgotten linear algebra and that sort of thing. And so I've been trying to reteach myself linear algebra, multivariable calculus, and statistics, which are kind of the foundational elements. And I got to admit, I'm struggling not having a professor in front of me to kind of, the books are, I don't know, I'm just struggling with that. What would you say to someone like me that really wants to understand how this stuff works?
So clearly you're taking the hardest path possible.
Of course.
You're not minimizing the distance. So what you should be doing instead is focus on your strengths. Your strength is going to be your subject matter expertise and your data. And then figure out at a model level, of course, you don't want your build to go up to the roof. So you have to figure out for your use case, what's the best model. And even though you've seen agentic reasoning with top of the line models, under the hood, there's a lot of much smaller models that are more statistical that are powering a lot of the AI. So focus on your use case, your data, figure out, your intuition should be what model is best at classifying, which model is based on reasoning, and then just pick from the models and use the tools. Actually, I didn't say it after the first question. Okay. But realistically, for this last 10-year journey, now it's much easier to get up to speed than it was 8 years ago. There's so many tools, there's so many good models, you just have to pick the right ones.
Okay. We got tons of AI stuff on the showcase floor, so people can come out and see us there. I want to thank all three of you for coming up here and being part of this today. I'm hopeful in 2 to 5 years we can all come back and say, were we right about our predictions about the future on that? So thank you all. I hope you enjoyed this. If you like this section, let us know. But thank you. We'll bring David Hughes back up.
Okay, thank you, John, special guests. You know, I'd like to conclude by circling back around to those industry challenges I discussed in the opening. We want to map them to the solutions we're providing with our security-first AI-powered network. The first challenge is those demanding users. We're addressing this with automated AI-powered assurance and troubleshooting. With an agentic mesh, we are taking this to a whole new level. The second challenge is around doing more with less. Our full-stack approach gives you leverage of a single platform to cover every aspect of your network, from the smallest branch through campus, through the data center. The third challenge is about those escalating cyber threats. Our zero trust-based framework with built-in security helps you move your posture into a much better place relative to those threats. The fourth challenge is around geopolitical risk. Those geopolitical risks can be addressed with our flexible deployment models. So you're not stuck with a one-size-fits-all public SaaS offering. If for your business the right thing to do is to be on-prem, we can support that. If you need sovereignty over for a country, we can do that. If you want to be running in the cloud and take advantage of cloud flexibility, but you want to control your own upgrade cycle and you want to encrypt everything and own your own data, we can do that. So Aruba Central, cloud-native software, but with many ways of deploying to suit you. The final challenge is that multi-vendor, multi-domain aspect of your jobs. I hope you've seen today the work that we've been doing with OpsRamp, integrating that multi-vendor aspect into Central, native. You never leave Central, you get that multi-vendor capability. But more importantly, our AIOps has full visibility. It's inferring and making decisions and recommendations based on seeing your whole network. Unlike others, where they have AIOps that's only seeing a slice or a part of what's going on. Finally, you could see our vision for multi-domain, where we're taking the AIOps, the GreenLake intelligence, not just applying it at the network level, which is what you saw today, but applying it across all of HPE, storage, compute, and networking. I'm super excited about where this is going. We're bringing it all together for you, the network operator in Central, but we're part of a bigger plan at HPE with GreenLake Intelligence. I also want to take this opportunity to thank you, our partners and customers. We really appreciate your support, your patience, your feedback. This is really something that we use to make ourselves better. I want to reaffirm our commitment to being customer first and customer last. For partners, there's a partner sales forum which follows this immediately. Highly recommend you go there. I'm sure you probably have already checked out the show floor, but if you haven't, make sure you do before you go. And then if you've got questions, tomorrow I'll be here with the rest of the Aruba exec team for Q&A. All questions are OK. So at this point, I'd like to bring back on the demo team. Thank you, demo team. And we bring this to a close. Thank you all very much. Thank you, everybody.